Hello everyone, today is the beginning of Chapter 5. We're doing Chapter 5, Lesson 1, Ratios and Proportions. A couple of vocab words to start off with. Number 1, we're going to go with ratio being a comparison of two quantities by division. Quantities would be defined as amounts. So if I'm talking about 3 apples, my quantity would be 3 apples, just so we're making sure we're clear on what the vocabulary word quantity means. So a ratio is a comparison of two quantities by using division. Essentially, we're talking about fractions here. Number 2, an equivalent ratio would be ratios that make the exact same comparison. And my example of an equivalent ratio would be number 3. Number 3, we have 2 boxes. One box has a total of 12 squares, and the other box has a total of 48 squares. Box number 1, the first one on the left there, we are going to shade in 7 of the squares, like so, 6, 7, and we are going to say that our ratio here of shaded squares to unshaded squares is 7 to 5. Important to know that we are doing a shaded over unshaded, a shaded to unshaded ratio. So 7 are shaded, 5 are not. We can express a ratio by using a colon, as you see here, as 7 to 5. You can use the word 2 and just say 7 to 5 without using a colon and just putting the word TO in there. Or, as I had said earlier in my definition, you can use a fraction such as 7 over 5. Now, just as a sidebar, if I wanted to express number 3 first box differently, or in a different ratio, I could express it as shaded over total. So if I was going to express the box, the first box, as the number of shaded squares, I would still have the number 7, but the total would be 7 plus the 5 unshaded for 12. So this would be a different ratio comparison if I were talking about the number of shaded squares over the number of total squares. Just as an FYI, because that'll come in handy when you're working through your assignments and your work. Ratios are dependent on what the problem is asking you to identify. So, an equivalent ratio would be 28 over 20. And the way, or the reason that would be equivalent is because 7 to 5 would be the exact same as 28 to 20 when reduced down. But first of all, let's express 28 over 20 by shading our squares in. So I have 1, 2, 3, 4, 5, 6, 7, 8 squares here. So this would be 16 shaded. This would be 24 shaded. And this would be 28 shaded. Okay, so we have 28 shaded, and then we would have 20 not shaded. So 28 to 20. The question is 28 to 20 the exact same as 7 to 5? And later on, we're going to find that 7 to 5 and 28 to 20 are the same, and we're going to show you how you would go about determining if those ratios are equivalent. So we'll come back to number 3. Number 4, we're going to find equivalent ratios simply by doing math. And the way we're going to find an equivalent ratio by doing math is we're going to multiply the numerator and the denominator in these cases by the same number. So if I multiplied 9 by 2 and 27 by 2, I would get 18 over 54. And because I did the same thing to the numerator as the denominator, 18/54 is going to be 18/54 will be equivalent to 9/27. Another thing I could do would be to multiply the numerator and the denominator by 3 and get 27/81, and so on and so forth. In reverse, I could actually divide the numerator and the denominator. In this case, I am just going to use a factor that creates a nice whole number, and I would get something like 3 9ths. And 3 9ths is the exact same thing as 9/27, as it is the exact same thing as 18/54. B, same situation. In this case, I'm going to divide the numerator and denominator by the same number, and I'm going to get 8 thirds is an equivalent ratio of 64/24. I could divide both of them by 4 and get 16/6, and all of those are going to be equivalent ratios, which means they represent the exact same amount or quantity. Number 5, a proportion would be ratios that are equivalent. So I keep saying equivalent ratios. We would say that they are proportional or they are the same. An FYI, green writing here, something to remember, something to write down in your notes. Equivalent ratios are identical when they are written in simplest form. Okay, they're equivalent no matter what form they're in, if they're equivalent, but when you reduce them down to the lowest terms, they will be the exact same thing. So if I move back up to number 3 and I look at my 7 to 5 box and my 28 to 20 box, if I reduce both of those numbers down into simplest forms, they would be the exact same thing. So in this case, 7 to 5 is in lowest terms. 7 to 5 is in lowest terms. You can't reduce that anymore. 28 to 20 is not in lowest terms because there's a common factor that goes into both 28 and 20. So I'm going to use a common factor of 4 because I know it is the greatest common factor for 28 and 20. 28 divided by 4 is 7. 20 divided by 4 is 5. Voila! 7/5. Voila! Already reduced to 7/5. Now we have proof that box number 3 and box number 4, with their shaded to unshaded, are equivalent ratios because when they're in simplest form, they are the exact same ratio, number, fraction, whatever you want to call that. Number 5, we're going to do a couple more proofs. Prove whether or not the ratios are equivalent, 3/5 and 9/45. The best way to do that is to reduce them down into simplest terms. 3/5 is already reduced down into simplest form, so I'm going to leave it as 3/5. 9/45 has a common factor of 9, so I'm going to divide the top by 9, the bottom by 9. 9 divided by 9 is 1. 45 divided by 9 is 5. 3/5 does not equal 1/5, therefore those are not equivalent ratios. 14/49 and 16/36. I have 14/49 not in simplest form. I know that 7 goes into both 14 and 49, and I'm going to reduce that down to 2/7. And I know that, let's see here, I know that 4 goes into 16 and 36, and that reduces down to 4/9. Both of them are in simplest form. They are not equal to one another, therefore 14/49 and 16/36, two ratios are not equivalent. Last thing would be word problems. Number 7 is a little bit tricky because it gives you some information that you don't really need to use math for, and that information is the first 2 words, or the first part of the sentence actually. At 4 degrees Celsius, it's important information, but it's not going to be part of our math problem. You'll see why in a moment. At 4 degrees Celsius, 2 cubic feet of silver has the same mass as 21 cubic feet of water. Notice I express cubic feet as Ft to the power of 3, and I express cubic feet with words. Both of them mean the exact same thing, just 2 different ways of doing it. So again, 2 cubic feet of silver has the same mass as 21 cubic feet of water when they're at a temperature of 4 degrees Celsius. Temperature makes a difference, as you know in science. Things freeze, things gain density, things lose density depending on temperature. At the same temperature, would 105 cubic feet of water have the same mass as 10 cubic feet of silver? So the question is, at 4 degrees Celsius, would 21 cubic feet of water, 21 cubic feet of water and 2 cubic feet of silver be equivalent to 10 cubic feet of silver and 105 cubic feet of water? So what we got to do is set up a proportion. So let's start with the first part of the sentence. 2 cubic feet of silver has the same mass as 21 cubic feet of water. So 2 over 21. At 4 degrees Celsius, they are the exact same. And we want to know at 4 degrees Celsius if 105 cubic feet of water has the same mass as 10 cubic feet of silver. So in this case, the 10 cubic feet of silver is going to have to line up with the 2 cubic feet of silver. So we're going to put that in the top for our numerator. And the 105 cubic feet of water has to line up with the 21 cubic feet of water in the other problem, or in the other ratio. So 2 over 21, reduced in simplest form. We're going to do our proof to figure out if these ratios are the same. 10 over 105 do have common factors. We can use 5. We can use 5. 10 divided by 5, we'll go back to this one. 2/21 is reduced. 10 divided by 5 is 2. 105 divided by 5 is 21. Voila! These are reduced down in the simplest form. They're the exact same. So in this case, 2 cubic feet of silver would be the exact same as 21 cubic feet of water at 4 degrees Celsius, as 10 cubic feet of silver would be the same as 105 cubic feet of water at 4 degrees Celsius. So the answer is yes, they would have the same mass. Good luck on your assignment for 5-1.